Hello guys, and welcome to part 4, the final part of the chemical property import series. Uh, so confession, I made a mistake in the past couple of videos. I forgot that we were trying to create a class this whole time. And so I was focused too much on the details and lost sight to give some context here. So here is my finished version of the code, and what we want is to be able to call the property of any thing in our database, and then to do something with it. In this case, do the function that finds the vapor pressure at a certain temperature, right? Extremely useful, gives us so many tools and so many cool things. But before, that's not what's happening. So we're going to make some fixes for that really quick before we get to this vapor pressure part of things. So, first we're going to have to get this all into this class for the most part, which, as you can see, not much is right now. So, the first thing that I'm going to do is to indent things properly. So, props to key, yep, it's in there. And then all the for comp stuff, that is in there. Though I should be careful. I should make sure to tab everything under it so that all the loops and ifs stay in the right spot. And for my insanity, I'm gonna do some spacing there. And then I'm going to insert this into there because we want to be able to do that every time for any component that we give it, and not just water and ethanol like we've been doing this whole time. So put it in, but actually have it in there with the right tabbing. Cool. And then let's see here. I know that there is more. I know that this is actually in the comps because we need to do it for every component. I was kind of lackadaisical on that before. And then also within this comp stuff is going to be all of this stuff that we made before. This is going to be a struggle to tab out correctly. Alright, cool on that front. And then you may have wondered before, what's this props to key about? We never used it. Well, there was a few things that I forgot before that is tied to this whole going into the class thing. Also, props, just for insanity. That's what I'm going to call it. Alright, but now let's get back to what I was just saying. I accidentally ran it, it works, that's good. So, in the right tabbing, I'm going to add something to the props to key there. to actually append it now with the processed props. Believe, yes, it is under comps, but outside of everything else. So yes, that is correct. And then I'm going to, you know what? The next part I was just going to say, or you know what, never mind about this. Let's add on this next part real quick. So now going out of the comps section here, you're now in the general class of everything. For each prop in props to key, now we're finally using the to key. Position 0, the first one. Keys of it, we're going to tell it. If self dot, ooh, I forgot something. So this is going to do some stuff to actually assign the properties and values to the class of anything that we call for. But before we do that, there's something that should be done at the beginning that should replace this, where we define comps as just first of all, this is just a more specific way to define comps real quick. Is instance this is just to avoid errors. And then, gosh. Alright. And then this is the part I was just referring to, sorry for the distraction. But n comps, this is the number of components. And this function len, which is, I believe, in the regular expressions stuff. Or no, that has to do with the it's a class thing, but it tells me the number of comps. Okay, so that's important because I had to jump up there because I'm about to use it right now because this is going to act differently if there's more than one component versus just one. So if there's more than one component, then the values that we're going to be going to eventually, or you know what, I'll just set that right away to let you know, because so it's not confusing. So we're going to do the class thing of setting an attribute self prop values. So that these can be called for later in the way of using the class. But and I should get this out of the if statement. But equals And then you can use a numpy array for this part. Comp prop for comp in props to key. Just a fancy way of getting to the value. And then the else just simply props to key the first element and prop. Alright, and before they run this, because it's going to do an error if I have to import numpy. So simply up here, import numpy as np, just so I don't have to type out numpy all the way. That's what the as does. And then hopefully this runs. Cool. Now we have a full class, but I want to do something a little more with it. I want to create a function within this class. Right now, it's just working off the initialize. You can call back things about the things in the class, and that's about what we have right now. But I want to do something with the class, and so for that, I'm going to define a whole new thing. So defining something in the class, but not under the initialize, that I'm going to call pvap f for the function that gives you vapor pressure, and that works on itself and some t. And so for this function, going to return JNP. And before I continue, this is Jack's numpy. It's just a new, faster version of numpy for certain types of operations. So we are importing jax.numpy as JNP. Sorry. Oop, I should run that. Doop doop. Cool beans. And essentially what I'm going to do here is like just, you know what, I'll show you the equation if I can find it very quickly. So Antoine vapor pressure equation. Or I think this might be it. But essentially, it's never mind. It isn't actually even this. Now that I look at it a second time, but there is an equation. The equation. Nah, jeez, I should stop spilling over myself. The coefficients for all of these are expressed as such and just a huge array of them. And effectively, correlations have been found where the first value plus the next value over the temperature plus the next value log of the temperature plus the next value times the to the power of the temperature and whatnot, it all factors into what the vapor pressure is according to the temperature or whatever thing is going on here. And so all we're going to do is we're going to do an exponent. So it's going to be exponent to all of these things. And to call the PVAP-A that is in the properties that, as we saw in part 3, we're just going to do self.pvat-A plus self.pvap-B over T. As I stated, it's going to be just taking all of these coefficients and doing various things with them. Times J and P dot log of T. And then since it's just going to be similar, I'll just copy and paste the rest of the operation real quick. And that should function. Invalid syntax. What's going on here? I don't know what all this is about. What am I? Oh, there's probably an extra parentheses. Is what I'm saying. Cool. And so now, hopefully, ignore that. I can say P water, just a variable, equals props. Or first, I should run all this. Okay, now P, so I want the props of water what am I missing? I've not seen this error before. What strings? Not defined. Yeah, this has to be string because I'm inputting component. Let me look at this. So it's around. There's probably just an indentation error is what I'm thinking. So it's around the single props down here. Let me look at my reference, single props, and then for kv single dot underscore props equals dot map. Alright, just so we're not here forever, I'm going to copy and paste this from my reference really quick. At least this section. See what happens. That's so odd. I have a feeling it might have to do with the comps up here. So I'm going to copy and paste that. Yeah, I'm pretty sure that's exactly the same. Yeah. Learning together, everybody. As you can probably tell. Oh wait, I think I might know what's going on here. Oh, in the copy and pasting process, I lost the defining of single props as a dictionary. I should have thought of that because it was telling me it was the wrong type, so I should have checked the type. All right, do that. Cool beans, we have that, and now, hopefully, for the grand finale, P water. Just random thing, property of water. That was what I was thinking. And then dot, and then now we have all of this stuff within the class. We have all these variables, but what I'm interested in, because we've already seen the variable part of this, is p vap, and then what's this one? This is fancy. This isn't the same symbol over here. It's a function, p vap f of, put in a temperature, it's in Kelvin, so I don't know, 300, boom, and there we go. We have, it tells us the exact vapor pressure of water according to this model very quickly, and I could get any variable I want in there, and I can devise many other operations within this system, and then quickly call back to it through a simple something dot the function of what I need. And so it's taken a while, but now we have seen the powers of classes and regular expressions combined. And it's been a wonderful journey. So, goodbye, and have a good day.